Okie dokie. Let's get it. Oh, fuck. Glasses. Okie doke. We started for just like a second earlier. So, sounds like we're going to be learning what exactly is going on with type conversion when we aren't doing it explicitly via static cast, which is the only explicit type conversion I know how to do right now. So we'll go till 2. Oh yeah, I need to set my alarms. Nah, that's fine. I'll go to 2 and then no break, and then I gotta go and visit family, and then do the self-test later on. Didn't do anything yesterday just because didn't have time to hang out with the family. Don't let this get fully in the way of that. I gotta learn as much as I can when I can. And then when I can learn more, I learn more. Nice. I got more time. Okay. Yep. From one type to another, type conversion. Cool, cool. Yep. Explicit is a cast operator. Static cast. Okay. And cast meaning convert, I guess. Or cast is the word for explicitly converting one type to another. A cast operator. So it's kind of like a unary operator. It's not like an operator, like a literal operation, like operator plus or minus or something. Where it's one character, it's literally static underscore cast, and then the angled brackets for the type we're casting to, and then what we're casting is the one operator here on the right side. So like whatever the value is. Yes, conversions don't touch the data that we supply. They simply take it and return a different type depending on stuff. It seems like they're encoding the type that's needed. Use that data as input, and then produces that result, meaning we pass in an integer, and then it says, hey, for an integer, do this, for this, do that, for this, do that. And it says, oh, okay, well, we are casting it to become a float, or rather, for implicit, there's a float variable receiving the integer, which means we have to convert it. So there's some sort of function, I guess, on the inside that takes an integer and returns a parameter and adds in the decimal. Temporary object that holds the result, which is then assigned. Yep, so just like a return value for any other function, where it returns some temporary object value that is assigned, or copy assigned from that to whatever is getting assigned the value. Okay. Makes sense. That's what conversions are. Oh. Interesting, okay. Hmm. I wonder if this is always, if might is literally might, as in this can be stored as this, or might be, but might not, might be stored some other way by a float, or is it always like that? I don't know. So what happens when we initialize a float with an integer? There's no narrowing conversion because we're not losing precision during this conversion. Losing information. Yeah, because integers store the bits for value 3 differently than a float stores the bits for value 3.0. So we can't just copy the bits. We have to somehow use some sort of conversion table or something to get them from one form to another. And before then, we have to determine whether that's acceptable or not. Well, I guess it's always acceptable. It's just if you use brace initialization, it catches narrowing conversions. And because brace initialization seems like it's the standard for C++, the safe, easy version, then that's something to worry about. But if you use copy initialization or list initialization, then maybe it wouldn't matter, like the parentheses initialization. Yeah, makes sense. Yeah, it would have some crazy float value. Because it wouldn't have been converted. Unless it just so happened that that's how it's stored in float too. That's going to be some crazy number. Yep. So 3. F is initialized to be 0.0. And then memory copy. Seems like that's what that is. Memory copy to where F is from, or we're copying to F in memory, and what we're copying is this from where N is. And then how many bits are we copying? Seems like you would copy all of them, but maybe that's not true. And we copy the size of a float. Couldn't you just do size of and then dereference this? Seems like that might be what you would do, but okay. So we're saying yes, we're taking int, moving its information into where this float is, and we need to also put in the size of the destination, which is a float. So the float stores 3 as this mega tiny number. So instead of that, we have to find out, we have to change the value so that it's storable by float f, because floats have decimals, which means this guy needs a decimal, and he needs a value after 0. And that is a value that float can represent. Seems like float can't actually represent 3, so the value that it's converted is, well, I mean, it's representing the value. But it isn't a value that translates properly. Hence the conversion. They don't line up properly. Okay. Let me get my phone real quick. What is happening? Okay, well, gotta cut it short. But I'll go for 17 minutes and then I gotta leave for a minute. Okay, so when does this conversion happen? It seems like with a value, the compiler sees, well, if it's already compiled, the processor sees, hey, we're moving this type of value to here, which doesn't translate automatically. It needs to be converted. Well, it doesn't match, so it has to be converted. So it then converts the value, then finds out what value in the destination, the target type, would represent that value, what bit sequence would, and then it changes it to that, and then boom. Or it just says it's that, and then boom. So it's like you could have a variable that's like the ASCII code for this, and then you have a variable that's a character, and it's the static not that. Like trying to convert from one letter to another. You add this specific number, and this other variable is initialized as what we start with, plus whatever, to get the final value. We're not actually changing that value, but we are finding what the corresponding value would be. That would work in this case. Yeah, so it's like and there may be different functions or like a template that behaves differently depending on the type. So in this case, it's like, oh, okay, this is an integer going to a float. Oh, we know that this is the conversion from an integer value to a float value. So we see, okay, like, what would we do? We would have, it's like, I don't know, is it a giant fucking switch case kind of thing? Where it's float, target value, and it's initialized to be thing, and then some manipulation of thing, something like that. And then we just return that. Or we could just say return. Oh yeah, because we can have temporary objects where we have like a standard something. What does that look like? Like that? There was a standard uniform distribution. Oh yeah, there's nothing like that. And then something so it has a range and then that. So couldn't we do a float like that? Oh. So I can print objects like this. Okay. So we could just float. Would there be an issue here because the narrowing conversion in terms of how much memory is being used for the data type? Good 3. 3.0. Standard character output kills the trailing 0. What about an int 3.0? Oh, really? Yeah, okay, I was about to say, what brace initialization? Are you doing your job, bro? Cool, so we can always do stuff like that. Yeah, so it would look, I was trying to figure out what the function would look like. It would be like target type, I mean in this case it would be float, convert to float, and then it's int, control value. What's happening? So there is no line 5. Are you tripping? Okay. Yeah, and it would just be like return a float that is initialized. And I'm just going to put the whole thing in parentheses. It's initialized to be. I don't know if we would initialize it. We would. So we take the value and we convert it to some value. So it's like some sort of taking 3. There's some sort of function in here. It's something that knows what value 3 should become. It knows that 3 needs to become 3.0 for a float to properly represent it. So it converts it to 3.0, and then it finds whatever that is. So like convert to appropriate value, and then yeah, something like that. Like convert to appropriate value, and then it's initial value, something like that. And then it returns the float value of that. Something needs to find what the float. Well, no, because that would be just finding the float value. That's not even right. It doesn't make sense. It would be like a I guess you don't need to convert the bits. You just find the value that works. So we're saying, hey, these bits, and they're stored this way for an integer. How do we represent those bits here? Well, before we do that, we actually have to change the value. So we do have to find the value. So it seems like this might even be an intermediate piece. We find what the value is, but the value is the same as the bit sequence. So we're saying it's like modify the bit sequence of the integer value and put it into a float version. And then it seems like we're done. We just assign it and return that value because the sequence is the same as the value. coercion. Makes sense. That would be called automatic. Yeah, so we're supplying an expression of type integer or of type character when we're expecting type string. And it seems like some of these are not automatically convertible. Really? I haven't done many implicit so far. Yep. Yeah, I don't fuck around with floats usually. Oh, like we have a string and we're returning a string view, maybe. Because we're converting from that value to a reference of the value. Or maybe there's like some sort of switch case that says, hey, or an if statement chain that says, hey, if we're returning a string view of a string, there's no converting craziness that needs to happen. Just return the address of the string. So just and the string. Float. Return that, and that's 3.0 because we don't have an F. Yep. And that brace catches narrowing conversions, so doesn't it catch? So saying 3.0, right? Yeah. Wait, no? Thought it would because double to float. Maybe, maybe not. Oh, you know what? It probably would. We're just not referencing it. Maybe it wouldn't now. Oh. Okay. Yeah, so if we're doing like unsigned int and signed int division, it converts everything to be unsigned. If we're doing integer float division, it converts everything to floats. I guess there's some sort of hierarchy there. It's not associativity. So it's the order of operations, basically. Well, that's precedence, but associativity is the the reading order, I guess you'd say, like which happens first. Like we start from right to left, but that's within something that's left to right, so it's left to right and then right to left, something like that. A non-Boolean, oh yeah, because we're converting whatever 5, which is non-zero, to true, which is to 1, which is true. Excuse me, and it sounded like in the previous self-test actually, the values are always represented as either true or false, but they can be used as 1 and 0 if converted. It seems like in this case we'd be converting from 5 to either true or converting to 1, which is true, something like that. I usually don't do this. You're passing some big memory shit to something here? Maybe you're passing tiny little 3. Mm-hmm. Yeah, the standard conversions, yeah, makes sense. Yeah, I figured there'd be some sort of like library or some sort of large table where it's like this value goes to this value goes to this is this. These are the acceptable values, here's this. Like you have 0, 1, 0. Okay, so we have 2 in binary. Oh, but over here it needs to be 0, 0, 1, 0, blah, 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 whatever. And it just, whoop, converts the bitch over. It says, you're this, you're this. But that's like a bajillion switch cases. Like trillions. More. Unless there's some sort of formula for converting, which there probably is. Compound types. Haven't fucked with those yet. These can convert to each other. Interesting. 14. Jesus. Huh? Yes! Alright, well, gotta go.